Hi everyone, Miss Andronicus here, and today we are using the term-to-term rule. So a sequence is a list of numbers or diagrams that are connected by a rule. Linear sequences are when the differences between the terms are all the same. So when we consider a term-to-term rule, here on the left we have a sequence of numbers. One of these is what we consider a term. So when we look at term to term, we look literally from one to the next and we look at the difference. So in this case, it's 16 to 10. So that's subtract 6, subtract 6, subtract 6, subtract 6. So because we can see a common pattern with every jump, in this case, the term-to-term rule is subtract 6, we can then apply that rule to find subsequent jumps or the next in the sequence. So if we continue to subtract, that's going to be -14 and -20. Have a look at this one. If we consider these jumps, that's going to be +3, +5, +7, +9. So we can see that it's not like the first example where the jumps were all the same. So the first one we know straight away is linear because the jumps were all the same. That was a linear sequence. In this case, it's non-linear because the differences are not the same, but we can still figure out what the next jumps are because there is a pattern still in the way the jumps are changing. So they're going up an extra 2 every time. So that's going to be +11 and that's going to be +13. So we know that's going to be 37 and 50. Okay, so 37 and 50, and we can find other terms along the way. Okay, so example 3, find the term-to-term rule and write the next 3 terms. So straight away, it's given us a clue. If it's term-to-term, that means that it has to be a common rule from one term to the next that's repeated all the way through the sequence. So that's firstly the clue. Let's have a look at the first one. That's +4, +4, +4. So we can see straight away the term to term in that first one is +4, and we can immediately carry that all the way through, +4, +4. So we've got 26 and 30 there. So that's that sequence, nice and straightforward. Looking at the term to term for the next one, we go straight to looking at the difference. So that's +1, +2, +4. Okay, so we can't have a term-to-term rule that keeps changing in this case. So we need to consider something else. Is there another pattern that we see there? So from 1 to 2, 2 to 4, 4 to 8, these numbers sound quite familiar. I think it's actually multiplying by 2 every single time. So there's other patterns like multiplication and division. And you'll notice with multiplication and division, the differences between them as they go up in the sequence and the numbers get bigger, the differences jump up far more rapidly. So the term to term in this case is actually multiplied by 2. And then you can continue finding the next 3 in the sequence by continuing to multiply by 2. Okay, not as common that you would find that, obviously, because this is not a linear sequence then, because it's not plus or minus, and it's not going up evenly between them, but there is a term-to-term rule because of the fact that it's multiplied by 2 every single time. Okay, the last example that I just want to go through is a kind of visual pattern type example. Now, when you have a pattern like this, often using a table helps you a lot. So it's like pattern number 1, pattern number 2, pattern number 3. And in pattern number 1, there's just 1 hexagon. In pattern number 2, there are 7 hexagons. Pattern number 3, there are 13 hexagons. So from this, again, we can have a look going across the number of hexagons. Is there a term-to-term rule there for us to find. That's +6, and that's +6. So we know that if we were to find the fourth pattern and the fifth pattern, term to term rule is +6 every single time. Okay, that's it, guys. Give it a go.